let me dig in. So I'm Josh Mandel. I'm the chief architect at Microsoft Healthcare. I'm a physician and a software engineer and have been working on FHIR and the Smart Health IT framework since basically the beginning. I've been the chief architect for Smart and pretty deeply involved in the FHIR community, trying to make it easier for developers to plug into clinical data. And I'm excited to share with you in this talk what I would describe as kind of an early preview of work that we've taken on in the Smart Health IT project that we're calling Smart Health Cards, so the Health Cards framework. And so I'll take you through first some of the motivation before we get into the details of the Health Cards framework itself. I'll show you a demo. Everything I show you here is based on open standards, and all the demos I show you will be backed by open source code. So if you want to dig in and try it out for yourself or understand it more deeply, that's all available. So let's dig in. And I want to start actually with kind of a detailed problem statement to give you a sense of what some of the challenges are here. Even in a world where we've made a lot of progress in terms of health data access. And thinking a little bit abstractly, the big challenge for me is that today, every time that you as a consumer start some new relationship with another entity on the web, you're starting from a blank slate. So as a patient, if you're going to see a new healthcare provider, you start with nothing. You fill out some forms, you tell them your email address, you provide a complete history, you're starting from scratch. And then if you go and register for an account with an insurance company, maybe you get insurance through your employer. Again, you're starting from a blank slate. Maybe your employer sends over some details about your name and address so they can check some things, but that's sort of special sauce. And as far as you can tell, you're starting just from a blank slate. And you show up to a new web merchant to purchase a medication or a medical device. Again, blank slate, register, new account, who are you? What do you need? All of this stems from this fundamental challenge of three issues on the web. First of all, identity. Second, authentication. And third, sort of frameworks for sharing and privacy. And I want to talk a little bit about each of these just so we've got a shared vocabulary over the course of the next 40 minutes. These are overlapping topics, but I'm going to try to draw some distinctions just so we can have precise handles. So identity. Here, I mean some notion of who are you? And that could be like, what citizen of a nation are you? It could be what qualifications do you have, but something about you or your history. And tied into that is the question of, well, how do you present that information to somebody? How do you make an assertion over the web or over the phone or in person to say, you know, I am Dr. Mandel, I'm a physician, I trained at such and such institution, and how do people check on those details? So that's all in the bucket that I'll describe as identity. Next up is authentication, and this is really just how do you sign in? How do you prove that you control a certain account? What protections should be applied to your account? Those sorts of questions are all about authentication. And then finally, sharing and privacy and transparency. This comes down to policies about where data about you are allowed to go and who should they be shared with, when can they move, who needs to get notified. Basically, what should I do to protect your privacy if you're going to be my customer or be in some relationship with me. And so we'll talk about each of these in turn in a little bit more detail. My thesis here is pretty simple, which is to say these are all basically a mess when you think about them at scale on the web today. So first of all, identity, like who are you? In the US, at least, there's two major approaches that we take to trying to solve this problem of who are you. The first comes with sort of in-person identity proofing. I show up at a clinic and I pull my physical driver's license out of my wallet and I hand it to the front office staff who reviews it and maybe looks back and forth between that license and my face and sees that they match. Maybe she makes a photocopy and puts it in my record. It's a slow process, it's expensive, and it's different every time, right? The policy that one organization has about which cards, which identities they're going to accept, they're all different. The nice thing about it, though, is that it builds on these existing relationships. I'm showing up somewhere in person, so there's a very high barrier to fraud. I can't show up at 10 million places in person all at the same time and see which 1% I can get through. I'm limited. So that's a real benefit to this kind of in-person checking. The other major kind of identity verification that happens is what's called knowledge-based identity proofing. And again, in the US, there's a number of kind of data brokers that manage these kinds of services. And from a consumer perspective, you get sort of a list of questions that supposedly only you should know the answers to. And if you answer them all right, then you've sort of verified who you are. And they can feel quite random. I mean, literally somebody might ask me the color of my car. They might ask me the name of a street that I did not live on in the past in a multiple choice list, all kinds of these little details. The nice thing about these identity proofing systems that are knowledge-based is they're fast and they're automatic, but there are a lot of downsides. And first of all, actually, it's still quite expensive because the services that do this just charge a lot. Their cost models are actually quite high. But more subtly, it promotes this kind of data hoarding because you can do a better and better job of offering this service if you can gather more and more data about individuals that are supposedly hard to learn. And so it drives organizations towards the collection of more and more personal data for these purposes. And it's also subject to breach. And we've seen this when one of these databases leaks. A tremendous level of detail about hundreds of millions of people can be stolen in an instant. And that is a real challenge. So answering this question of who are you today is still very difficult. Let me move on to the question about authentication. And I'll just mention a couple things briefly here. But every website you want to sign into, every merchant or vendor has its own system. Sometimes it just means you make up a new username and password for every site. Basically, human beings are not good at that. So either you use a password manager and maintain different passwords for every site, or you just sort of use a shared password and you recognize that if your password is cracked in one place, somebody's going to get access to all of your accounts. That's sort of been the status quo for a long time. Two-factor auth improves the situation by quite a bit by making sure that just stealing a password alone is not enough to compromise your account. The workflows for two-factor auth are quite varied. They use a bunch of different second factors. Could be a standalone app, could be a secure message, SMS rather, or an email, all kinds of different approaches. And as a consumer, what that means is that you have to use all of them, because if you use 10 different services, each service tells you what to use with them, and now you've got 10 apps or SMSs or email sort of workflows that you need to be able to use. And then the other major approach for authentication is single sign-on. So using an external identity provider, maybe I sign in with my Facebook or my Google or my Microsoft account to a site and use that identity to access third-party sites. And that can be quite convenient. It's actually great in terms of the security properties because the teams at Google and Facebook and Microsoft are quite skilled at monitoring for strange activities and flagging things. So the security properties can be quite good, but there are some privacy concerns here. First of all, it gives rather centralized control to a small number of these identity providers. And if you lose your Google account that you've been using to sign into all of your services, suddenly not only have you lost your Google account, but also you can't sign into those services anymore. So the control issue there is a challenge. And then tracking is another challenge. It means that now my identity provider knows everywhere that I sign in on the web. They can follow me across the web because every time I sign in, they're involved in that conversation to help me do it. So that's really a pretty messy situation as well. And then the last area that I'll describe on this front is sharing and transparency. And I will say this is certainly a US perspective, sort of sharing what most US residents outside of the state of California experience today. And this situation is better under some other regulatory regimes. I think it's better under CCPA in California. It's better under GDPR for European citizens. But these are still very real challenges. And so in the US, healthcare data is shared under a framework called HIPAA. And the short thing to say here is it's really opaque to consumers. There's a bunch of ways in which your data can be shared, like your hospital can share it with many different parties for specific purposes. And as long as they've got the right sort of agreement in place, that's allowed to happen. And so from the consumer perspective, this can be, let's just say, surprising and distasteful, even if it's perfectly legitimate, and even if it perfectly follows the letter of the laws and the regulations. In theory, a consumer can say, could you please give me an accounting of disclosures? Can you, Dr. Jones, please tell me all the different places where my data has gone? And in theory, you can ask for that and get it, but it's very hard in real life to get anything useful from that conversation. And then there's also separate pathways for data that have been de-identified. And I sort of put that in air quotes, because in practice, the more we try and the more we learn, the harder it seems to properly de-identify these data in a way that they really can't be linked back to an individual. at least if you don't render them useless. If you strip away enough information, maybe you can achieve that goal, but now you can no longer sort of accomplish the things that you want, maybe answering research questions or training machine learning models. Those things get harder the more that you strip away. And a lot of the national frameworks for healthcare data exchange are based on a pretty challenging underlying model. These are frameworks that allow one doctor in one hospital to sort of ask all the other health systems, hey, do you have any data about this patient? I'm seeing this patient now, but I don't have their clinical history. Does anybody have anything to tell me? And the way those systems work today is patchwork. They don't work very accurately. And all of the matching is sort of based on probabilistic demographics-based matching. So I'll say, I've got this patient with the following name and phone number and address. Do you have anyone who looks like this? And all of the other healthcare providers in that network will sort of scan through their databases and see. But it's always a probabilistic kind of match. So there's false negatives, there's false positives, and it can be a real challenge both to make the data flow when they're supposed to, but also to prevent data from flowing when a consumer would want to keep different aspects of their record separate, partitioned. So giving individuals these controls over how their data are shared and giving them insight or transparency into that same question is also really today a mess. So I'm going to shift gears then. I've introduced sort of the problem statement in about 10 minutes. Now I want to share with you some of the technologies that are on the horizon that I think might help. And I want to be fairly measured here. I'll say some things that are sort of evangelical perhaps, to say, here's a set of standards that I think could really make a dent in things. But I also want to say it's early. We're still learning a lot. There's a lot of exploration to be done. And some of the foundational standards are still in draft form or still being written. So what I'm pointing to is very much work in progress. And I would say if it's interesting, I've got links in this deck to the organizations where you can get involved. So one of these that I'll point to first is focused on authentication. And it's the notion of a decentralized identifier. And the idea here is that you as a consumer or a business or any entity on the web, you can create your own identifier and do it in a way that's bound to some sort of cryptographic keys. So maybe you generate a key pair that's stored securely on your mobile phone. And from that, you have now an identifier that people can use. And the interesting thing about these decentralized identifiers is they're designed to be unforgeable. So just by knowing your ID, I can know something about the cryptographic material that went into it. And I know that no one who didn't have access to those keys could have provisioned that ID for themselves. It's an interesting concept that really pushes a lot of control out to the edges of the system and lets people sort of create these identifiers for themselves. There's a whole bunch of different methods for doing this. And so the specification that I link to here for decentralized identifiers is sort of a framework. And then there's lots of different specific methods that follow this framework. So you can think about decentralized identifiers as kind of a pattern for giving consumers or other entities this level of control. But inside of this pattern, you can generate this identity securely on your device. You can protect it with a PIN or your thumbprint or whatever else your mobile platform supports to protect that cryptographic material. And then when you want to authenticate somewhere, you basically, on your phone, unlock access to that key and explicitly choose to sign in somewhere. And the nice thing about this is that your keys live on your device, and there's no centralized tracking when you sign in. There's no centralized identity provider who can track who you are or where you're using this identity, because you've created it for yourself, and you can share it and use it only when you see fit. And at the core, I mentioned that the decentralized identifiers framework is sort of a template. But at the core, this is the key idea. If you know somebody's DID, as you see in this example one figure here, if I know your DID is this string, then there is some algorithm that I can follow to resolve your DID and retrieve what's called a DID document. So that's what you see in example 2 here. And your DID document basically has a list of authentication keys associated with you, and then potentially some other metadata as well, maybe service endpoints on the web where a client can go to get more information or interact with an API. So it's a very simple abstraction. You as a consumer control this identifier, and then anyone out there, if they have your identifier, can then find your DID document and figure out how to take next steps. Those might be next steps for authenticating you. They might be next steps for learning where they can go to request access to your records, anything you want. So that is the first foundational standard that I want to point to, and it's very helpful for authentication. And then building on top of those decentralized identifiers is a standard also in progress from the World Wide Web Consortium called verifiable credentials. And the idea here is really nothing new. It's just a signed format for representing a set of claims or a set of details about an individual in a way that is tamper-proof. So it's basically, you can think about a verifiable credential as being a lot like a physical card that you would keep in your wallet. It has a set of claims. Maybe it says, this person's name is Josh. He graduated from such and such school. His grade point average was such and such. And that whole bundle of data is signed by whatever entity issues it. So you can imagine a health insurance company creating one of these verifiable credentials bound to me that says what kind of insurance plan I have and when it expires and maybe what level of benefits. You could imagine a state or jurisdictional registry of motor vehicles issuing one of these cards to say that I'm a licensed driver. The concept maps really nicely to something that consumers are familiar with, which is just the pile of cards they keep in their physical wallet. And the nice thing about having a set of these verifiable credentials is that you can mix and match them. If I've got one that talks about my medical license, and one that talks about my undergraduate education, and one that talks about the fact that I'm allowed to drive a motorcycle or ride a motorcycle, and somebody needs to see some combination of these in order to rent me a vehicle, I can pull out the right set of cards and share them. I don't need to create some special thing just for this one interaction, because I can mix and match the cards and claims that I have in the equivalent, in my digital equivalent of a wallet. And this opens up one really interesting possibility, which is that identity proofing step we talked about when we were introducing the identity challenges. We said that's really expensive to get somebody to verify all those attributes of who you say you are. Maybe they have to call up your university and do a lot of research, and it takes time. But now we can amortize that cost. Because if somebody does that research and verifies that you are who you say you are, that you have this degree, they can write that down in a signed package, which you can use and reuse over time. And so if you get to use that card 10 times, it means the marginal cost is shrinking because you only had to do the actual legwork once. So that's very powerful in terms of the economics of making identity proofing scale. So this is a figure from the verifiable credentials specification, just to give you a sense of the conceptual model here. But there's three important entities that you see running across the top of this slide. First of all, there's, well, I'll start in the middle. There's a holder. This represents a consumer, maybe with a mobile digital wallet that they use where they can keep various cards. There may be a number of issuers. So these are the organizations that create a card and give them to that consumer. So that's called credential issuance. And then when a consumer wants to share certain credentials with another party, that party is called a verifier. So if I give you a set of verifiable credentials and you check on all the signatures and make sure that they match what they're supposed to, you're acting in the role of a verifier. And each of the interactions between these parties is governed by a set of open data formats and open standards. And that's really the key, because as a consumer, it means I get my choice of different apps and tools. I can work with any number of issuers that follows a common set of protocols, and I can share the cards that I have with any number of verifiers that follow along with those same protocols. So hopefully this is some good food for thought. We've looked at some of the challenges. We've taken just a small peek at some of the emerging standards that could help here. What I want to do now is try to tell a story, a very concrete story about how we can stitch these pieces together and solve for one set of use cases in the context of COVID-19. Nothing about what I'm going to share is limited to or tightly bound to COVID-19, but it's quite helpful to have a specific model in mind. So I'm going to present to you the Smart Health Cards framework that uses decentralized identifiers and verifiable credentials to accomplish a couple of goals. Really, what we want to do is put consumers in control of managing their own lab results and their own immunization or vaccination records, so that they can share those lab results and share those vaccination records when they see fit. And this is kind of a thorny problem clinically, because the semantics of lab results and immunizations can be kind of complex. The science has been evolving very quickly. There's lots of different lab tests that reveal different aspects of maybe whether you are currently infected or whether you've been infected. And to interpret these things properly means understanding something about the actual laboratory assays that were done. Of course, we're on the cusp of seeing Many vaccines come onto the market, and again, those will have their own different properties. So the clinical semantics are really important here, and they're challenging, and they're a moving target in terms of how do you interpret a lab result, or how do you interpret a vaccination record. And we want to leverage FHIR for those clinical semantics. We also want to be able to accomplish some really specific use cases in a clean way. So for example, if I want to go back to my physical work office, maybe I want to be able to show just the right amount of information that should get me back into the office. If I want to get on a national or international flight, maybe there's some records that would help triage. So these specific use cases may have some of their own requirements, and we want to understand those things well so that we can have the right recommendations for them. And then, of course, everything here should be based on open standards, so we can have many different organizations issuing and verifying these credentials. There should be competition in the marketplace. And really critically, we do not want to require any kind of pre-coordination. So if some verifier wants to show up tomorrow and ask me for access to some lab or immunization records, that verifier should not need to have a relationship with the lab that gave me that test 5 months ago. These things should be able to be late binding. So those are some of the goals. Let's just think about what happens today so we can highlight what some of the issues are. So maybe I have a laboratory test, maybe a blood test. I get some results a couple of days later. Maybe I get an email with a link to those results in a portal somewhere. Maybe I have a mobile app that can fetch those results and show them to me on my phone. If I'm really lucky, the healthcare provider or the lab that generated those results might even have a Smart on FHIR API turned on, and I can connect a third-party app and fetch those results from it. So there's already quite a lot of ways where data can flow. And I'll show you this example. Back in May, I had a test done at LabCorp. It was an antibody test, and I got a couple things back. I got a PDF, and these are all public in GitHub if people wanted to dig in. The links are in the deck. I'm comfortable sharing this information publicly, and I find that even having a few examples can be quite helpful for spelling some of this out. So I got this PDF that has some information about who I am and where I live and my phone number, my birth date, my gender, a fair amount of personal detail in here. Information about who did the test, when the specimen was collected, and then the actual antibody results, which was a negative IgG result for the SARS-CoV-2 antibody, and then some details about the specific test methodology that was used. So I've got this PDF, and I can print a copy out. I can show it to anyone I like, and I can demonstrate to them. Well, in this case, I'm not demonstrating much. I'm just showing that I had no evidence of prior infection, but I can demonstrate that to anyone I want. What's missing, of course, is the ability to verify this, because I can also download this PDF in a PDF editor and change the details of this result to show, I could change the word negative here into positive, and I can print that out, and I can show that to anyone that I want. So that's kind of a gap. Maybe there's enough social trust in a lot of situations that I'm willing to take your word for it, and the document is just acting as a little bit of extra evidence. So I'm not saying this is a terrible situation, not at all. I mean, having this kind of document and being able to share it is very helpful, but you also want to understand the limits or the boundaries. And in this case, one of them is that somebody can tamper with this document. Same exact thing with these FHIR payloads. I was able to, with some help from a colleague who had access to a registered client with LabCorp, I was able to fetch FHIR data associated with that same diagnostic report, and I uploaded that to GitHub as well. It's really just capturing the same kind of information that I showed you in the PDF report itself, but now we've got LOINC codes and LabCorp internal test codes and this coded result saying that it was a negative interpretation. Same opportunity. Maybe this is a little better because it's interoperable data. And if I want to upload it to somebody and they want to verify that it's negative, they can do that like by executing a FHIR path expression rather than making a human being carefully read through it and figure out where the result is. So that's a real bonus. But of course, just as easy to tamper with. I can change that little N into a little P, and now I've got a positive lab result instead of a negative lab result. So those are some of the challenges. But it's worth emphasizing that this paper or even FHIR API-based approach is loosely coupled, and that's really nice because people can mix and match these data however they want. One other approach that you can use here, which would avoid this challenge about tampering with the data, is instead of downloading my result and then sharing it with you, I can authorize you to access the API for my account in LabCorp. And the nice thing there is so I can directly connect a verifier into my LabCorp account using like a Smart on Fire app launch. And now they can see the data is coming straight from LabCorp. And they know I'm not tampering with it because I'm not part of the loop. So that's one way that you can get a better guarantee with respect to tamper-proof data sharing. You get data right where they need to go. The verifier sees it directly. So that's a win. But there's a couple of downsides to this approach. First of all, you might be dramatically oversharing data. If all I wanted to do was share one COVID lab result, but all I can really do is share all my lab tests, suddenly I'm giving this verifier the ability to access much more than they really need. And I have to sort of trust them to only retrieve the things that I want them to. Granular permissions in Smart should help here over time, but this is always sort of a big challenge. And the other couple of issues are, first of all, it requires pre-coordination. So that verifier needs to be registered as an app. In my example, they'd have to be registered with LabCorp ahead of time before they could connect. And then the other issue is just privacy and tracking. If I make those connections between every verifier and the lab who issues my result, suddenly this lab can track me all across the web and across the physical world. Basically, every time I want to use the result, the lab gets a ping because it's coming from their API. And depending on your trust model, that might be a perfectly fine risk, but it's something new that you don't necessarily want. So how do we improve the situation here? I'll show you a very quick demo, which is hosted at c19.cards. That's COVID-19.cards. And this is an open source, very simple health wallet demonstration. And this is not a real secure app. I'll be super clear about that. This is a toy, but it's useful for giving developers a sense of what's happening under the hood. And so if you do check this out, I would say definitely open developer tools. Everything that happens in the app shows up in the console here as a logged change. And we print out the entire state of the app and all of the keys and all the intermediate data. Everything shows up there in DevTools, so you can see what's happening. But by default, every time I load this app, it's going to generate a new decentralized identifier for me based on a public key that it's creating. In real life, you would want this to be stable over time. And also in real life, you would never show it to a human being because it's like some scary random collection of letters. So again, this is a developer tool. But the idea is I can connect this to an issuer. So a laboratory that's going to give me a COVID lab result. There's a few ways I could do that. One thing I might do would be to directly scan in a lab result, maybe from a QR code or maybe directly upload a file. Maybe I can go to my lab portal and make a connection between that portal and the app. That would be one workflow. We also have a Smart on Fire based workflow for this. So if I choose connect with Smart on Fire, and if my lab supports Smart on Fire, we've defined a Fire custom operation that issues credentials as well. So this can be basically done with one click. As long as I give my lab API, in the lab API, as long as I give access to this mobile wallet, then the wallet can go to the lab and say, hey, do you have any credentials for me? Please issue them to me and I'll store them. And so that's what I've done here. I've gotten now one verifiable credential that is based on 7 Fire resources. I'll show you what that means in a minute. And maybe it has some conclusions about whether there's been evidence of certain infections in the past. Now, these get stored securely in my mobile wallet. And at some point, I want to go use them. I find a verifier that might ask me to show them evidence that I have these results. And a simple thing they can do is present a QR code here, asking for me to basically share those results. And I could scan that QR code from my mobile health app. So in the wallet, I can click this button to scan a QR code. I won't use my camera because I'm already using the webcam for this presentation. So I'll just paste the URL instead. But normally this would be a scanning step. And then I get a prompt in my mobile wallet that says, hey, it looks like this venue is trying to get access to your COVID vaccination records or COVID lab records. Do you want to share those cards? And I get an explicit choice. If I choose to share, which I will here, then those results are submitted to the venue, and the venue gets the results to display directly inside of their tool. They get the same cards that I had in my wallet now on their end. So that's a very simple demonstration of how these tools can be assembled in a workflow that allows consumers to present these cards when and how they see fit. I'll say a couple of things about the underlying technology here. First of all, that interaction that you saw between the venue and the mobile wallet, that's based on the OpenID Connect standard. So it's based on this widely used standard for single sign-on, but with an interesting tweak, which is the OpenID provider that I'm using is not like Google or Microsoft or Facebook. All those companies do offer OpenID providers in a centralized way, but in this demo, the OpenID provider that I'm using is what's called a self-issued OpenID provider. Self-issued OpenID provider is SIOP, and so that where you see that phrase here, decentralized identifiers and SIOP, self-issued, means that the OpenID provider is actually a mobile app that's running on my phone or a web app that's running under my control. And it's playing the role of that provider. So it is seeing the request to sign in or to share certain claims. It's giving me the opportunity to say yes or no, and it's submitting the result directly back to the verifying party in this workflow that could be based on redirects, just like a regular OpenID workflow is. But instead of redirecting out to a Google or a Microsoft, I'm just redirecting to a native mobile app on my phone, or in my example, to the C19 web application. And the cool thing about that is it's totally self-contained, or it can be. And the entire provider stack can be running on my own device. And what happens when that request is made is the initial request comes with a set of data requirements or data claims that the relying party, the verifier here, wants to see. So it might say, I'm asking for access to your COVID cards, or I'm asking for access to all of your immunization records. Based on that specific kind of data that's being requested, I can get a prompt in my mobile wallet asking me what I want to share. And then those results are signed and sent back to the verifier. They're basically uploaded to an endpoint that the verifier has specified here. And then the verifier can validate the signatures on what I've submitted. Inside of that payload, they're going to get a set of verifiable credentials. And the verifier can go through each one of those and check the signatures on those. And so that allows the verifier to make sure that I, as the holder of these cards, was really the one who's shared them. And it also allows the verifier to tell that, for example, LabCorp was really the one who issued those credentials in the first place. So you get provenance of the credentials and provenance of the presentation of those credentials all built in. And so this is a framework that we're calling Smart Health Cards Framework. The core documentation is here at healthwallet.cards that goes into detail in terms of this underlying conceptual model that we've talked about, in terms of the protocols based on OpenID Connect, as well as some detail about the data that flow over the wire. So I'd encourage you to check this out if you're interested in learning more. I want to share a couple of notes to talk about some of the data that's flowing over the wire here and our approach to doing the modeling for the credentials themselves. Because if we want an interoperable solution, we need to be fairly precise about what goes into these credentials. So I'll give you just an intuition about this in the next 2 minutes or so. And so in the spec, we have this page about the data model. And the high level intuition here, zoom in so this becomes readable, is that we're going to have two kinds of resources, FHIR resources, inside of our bundle. So we're going to have, first of all, we're going to say what version of FHIR we're using, and then we're going to provide a FHIR bundle right inside of this JSON credential. Inside that FHIR bundle, we're going to have some content resources. So these are things like diagnostic reports and observations and immunizations. And we're going to have some FHIR identity resources, and this would typically be with the FHIR patient resource. And so what I'm giving you is a small graph of data, maybe just a few lab results and one patient record, all linked together in the appropriate ways using FHIR. And this takes advantage of some of FHIR's interesting bundle features. So specifically, when we look at this bundle in FHIR, every entry here is given a UUID as its full URL. And so when I want to link from a diagnostic report to a patient, if I just search for this, I'll see some examples in this document. So here's my diagnostic report that's referencing that specific patient as the subject of the report. It does it using the full URL. What that means is this bundle is entirely self-contained. I don't have links out to a server somewhere. I don't need to reveal the underlying resource ID where these things originated at the source, but I basically just cast each of these as a standalone FHIR resource identified by a UUID. And my tiny graph of just 3 or 4 resources is all correctly linked together so that it can travel together as a unit. And that's the basic intuition for how we're modeling those data. Of course, there's a lot of open questions about what fields are required on the diagnostic reports and the observations. How much detail do we need to share about where the tests were done or which laboratory assay methods were used? And so we've got all the flexibility of FHIR to try to iron out some of those details. I don't think we'll have time today for one thing that I listed as sort of a bonus topic, but I'll just mention one challenge here is going from these low-level lab results to a high-level conclusion, like, should I let you into my building or should I let you on this plane? And we're very much not trying to solve that high-level problem right now. We're trying to make sure that people can share the low-level inputs that you would need for some of those higher-level decisions. And that allows trusted entities to come into play that might gather several kinds of data, maybe some verifiable credentials, maybe a direct-to-consumer questionnaire or survey, and then by combining all those results, they can reach a conclusion about what to actually do in the real world. And so that's a really interesting and rich topic that we've tried to keep separate. And before we open up for questions, I only see one in the Q&A right now, so I'll take a couple more minutes then to share just a couple more aspects of this ecosystem that I see emerging that are worth knowing about. And so this is outside of the smart health cards framework itself, but part of the general sort of decentralized identity ecosystem. So one is the concept of a consent receipt, which is to say, anytime I give consent to share my data, it would be nice if I could get a receipt that reminded me of who now has my data and why I gave it to them and how long it lasts. And what that means is then I can have sort of a file folder virtually of all these receipts. And at any point I can say, how many different entities am I sharing my data with right now? Oh, how come that one hasn't expired yet? Let me go check on this. And it gives me that kind of a link back into my previous sharing decisions and allows me to review and make changes over time. So that's one area that's pretty interesting for me that we're sort of missing today in the digital world. Another one that I'll just point to briefly is this concept of a personal data hub, which is to say, rather than just storing these kinds of identity cards on my own mobile device securely, I got to recognize that my phone is not always online. And when it is online, it doesn't always have the best bandwidth. And it would be nice if certain service providers I wanted to work with could actually access some storage space that I allocated for them in a secure kind of cloud environment. And instead of just storing my data on their servers, I could ask them to store my data in my personal hub. And so there's interesting standards work going on in the space of secure data stores that I'd point to as well as a really cool future direction that provides consumer control for this kind of sharing. A couple notes about where some of this work is happening. So I mentioned the core standards of decentralized identifiers and verifiable credentials. That work is happening chiefly in the World Wide Web Consortium. There's also the Identity Foundation, the Decentralized Identity Foundation, DIF, where a number of these adjunct specifications are being built. So we talked about DID SIOP for self-issued open ID providers. That specification is being developed here in the Identity Foundation. And several others, including secure data stores, which is joint work with the World Wide Web Consortium. So this is a great place to check out if you're interested in these topics and you want to roll up your sleeves and get involved in some of the early development of the specifications themselves. With that, I think I'll pause and turn over for questions or discussion with the group. I see a couple of questions already in the Q&A, so I'll start there, but I will encourage folks to ask more as we go. So first question is, how would a possible implementation of these cards be in an EHR? Could they be used in the context of clinical decision support? So yes, I think my perspective would be any entity that is in the position to issue these cards is a potential issuer in this space. And the EHR is a really good fit here because it often captures the clinical records of a whole variety of different tests that are done, immunizations that are given. So I would think of my EHR as one of the primary potential issuers for these verifiable credentials. I would think of commercial labs, which I talked about in the examples, as another major case. And I would think about retail pharmacies as another major case of health-related issuance for verifiable credentials. Could they be used in the context of clinical decision support? Absolutely. Plain old FHIR data can also be used in the context of clinical decision support. And inside these verifiable credentials is just plain old FHIR data. So from a technical sense, the answer is yes. As far as whether you need this extra degree of trust, it depends a lot on who's doing what job. If I'm a consumer and I'm trying to get decision support for myself, it doesn't really matter whether I'm using verifiable resources or random stuff that I typed in, because I'm responsible for that chain of custody and I'm taking the risk. And so verifiable credentials might not give you much of a boost in terms of trust. But if I'm a healthcare provider making a set of recommendations on behalf of someone, this can give me greater trust that the data I'm using are at least correct, if not complete. So that's a little bit on that front. There's another question